If you're getting ready for A-level chemistry paper 2, then don't mix up ozone and greenhouse. The ozone layer absorbs UV light and it's really important for talking about CFCs, whereas greenhouse gases absorb infrared radiation because of their polar bond. If you've managed to successfully make a pure sample of an organic substance, then it's going to have a really sharp melting and boiling point. If you're testing for alcohols with potassium dichromate, make sure that you say it's acidified. And when you're doing that, make sure you're describing colour changes. It goes from orange to green. It's not enough to just say it's green. Make sure you've revised your CIP priority. When you're looking at the 4 atoms around the carbon-carbon double bond, you need to be comparing their atomic number. And if they're all the same as each other, say if you've got 4 carbons, then you would then go on and look at the atomic number, not the mass, of the 3 atoms that are also bonded to each of those carbons. The empirical formula is the smallest whole number ratio of the elements in a compound. So once you've worked out the moles, divide everything by the smallest number of moles, and that will give you a 1 to something ratio. If it's within 0.1 of a whole number, then you can probably round, but any further than that away and you're going to need to do a little bit more. So say if you've got 1 to 1.5, double both sides. If you've got 1 to 1.33, triple both sides. If you've got 1 to 1.25, quadruple both. And don't forget that you need to give that answer in the form of a molecular form. So CH2, not just 1 to 2. When you're looking at IR specs, make sure that you're not getting confused between the OH alcohol group and the OH carboxylic acid group, or the C double bond O and C double bond CP. And double check that you know actually where the fingerprint region is and what it's telling you. When a CFC breaks down in the presence of UV light, it's going to produce 2 free radicals. Fluoroalkanes and chloroalkanes have stronger bonds than bromoalkanes and iodoalkanes. So therefore they need more energy to break the bond, and therefore they react more slowly. And then don't forget that all the physical topics from 2 to 6 and also number 9 can still be examined in paper 2. So make sure you're on top of all the things that we talked about in the paper 1 video, like making sure that when you're writing an expression for Kc, you use square brackets, but when you're writing an expression for Kp, you don't. Or making sure that in those Kc expressions, you're using concentration, not number of moles. Or remembering that as a general rule, metals don't make molecules. Shut up, aluminium, nobody asked you. So if you're writing about sodium chloride, you don't want the word molecule anywhere near your answer, because one mention of intermolecular forces is going to remove all the credit that you got for those strong electrostatic forces of attraction acting in all directions between oppositely charged ions.